Welcome to Beer and Philosophy. Cheers. So I've been building up to the idea that I identify myself as a rational empiricist. In fact, I would go beyond this to say that that is what the scientific method leads towards. That scientists are, if they're doing science well, that scientists are rational empiricists. And so I would identify myself as a rational empiricist. What do I mean by this? So I take in data from my senses, empiricism, and then I apply rationality to those sense data. So I think, to me, both are important. I guess historically in philosophy, there's like a bit of a debate, conflict between rationalism and empiricism, and I would say that we need both. To me, this just seems kind of obvious, but anyway, and I think probably a lot of people would be in that same camp. They would agree. So yeah, we need to. Our senses can be fooled. This is part of the problem. This is why we can't just rely on our sense data, because you've probably, for example, seen an optical illusion at some point in your life, and so you know that merely, there's a saying, "Seeing is believing." Well, that's that. You might want to be skeptical of that saying, because just because you see something does not necessarily mean that it is true. So our senses are not to be fully trusted. That being said, we hopefully can trust them to some degree. Things like, are you a brain in a vat, or are you a computer simulation, or whatever? Is there an evil genius, as I guess Descartes would have said? These things kind of call into question somewhat how much we can trust our senses. So there's that. But I'd like to think that by and large we can trust our senses to some degree, and especially if we're careful, right? If we make multiple measurements and we try and account for possible sources of error and so on. So there's that. Now, what about rationality? If someone wanted to be just a pure rationalist, what would be wrong with that? Well, one of my introductory philosophy professors pointed out this, I think it was, I want to say Galileo. But who proposed the following, thought experiment. So at the time, it was believed, I think it was Galileo, right, who drop the two things from the Leaning Tower of Pisa. If I've got the details correct on that, I'm not sure, but you can tell me I'm wrong in the comments there. So the thought at the time was that heavier objects fell to Earth faster than light objects. And you can kind of see how this would be reasonable, I suppose. So that was the belief. So Galileo used a thought experiment to show the shortcomings of thought experiments. And so he's like, okay, so think about two, I guess like cannonballs, so large metallic objects. And so one is, much larger, say 10 times larger than the other, right? So you got, a tennis ball sized, cannonball, and then, a bowling ball sized cannonball, or something like this. And, which is going to fall faster? So the sages of the time, those in favor of a rationalist approach and thought experiments, would say, of course, the heavier object will fall faster than the light object. Okay, cool. So Galileo's like, okay, well, so think about this then. So what if we attached a chain between the heavy and the light objects, and now they're attached? What would happen? Would the heavy object pull the lighter object down faster, or would the lighter object pull the heavier object up, and thus slowing it down? What do you think would happen? And then, so whatever answer a person might go, oh, I don't know, let's see, it could be this, could be that. They debate, again, this thought experiment that they're doing in their heads to try and figure it out. And then Galileo, if I'm correct about it being him, throws this monkey wrench in the thought experiment by saying, haha, but if you think now there's this other object which is composed of the bowling ball and the tennis ball and the chain, that's actually heavier than any of the components on their own. So, of course, if it's true that heavier objects fall faster, then, of course, that should fall faster than anything. Thus showing that the whole system is incorrect here. So then, anyway, so he used thought experiments to show the inadequacies of thought experiments, and then went on to, actually empirically drop two objects of differing weights at the same time, and found that they actually reached the ground at the same time. We now know that heavier objects. So we actually know if he was more precise, he actually would have found that they didn't reach at exactly the same time, because there's confounding variables. One of which is air resistance, and the other of which is, if I understand correctly, they would reach the center of the Earth together. I might be wrong about that, because the gravity vectors may negate that one. But certainly he was not aware, well, I don't know if he was aware or not, but certainly air resistance would play a factor, play a role here. Anyway, close enough that they landed at the same time. And so, thus sort of lending support to this idea, of using empirical approaches to discover reality, and to the idea of gravitation. So I would contend that we need both. We need both empirical data and rationality to process and make sense of those data.